Okay, it is time to get started. So far, we've covered the basics of sort of creating markdown documents, something that I expect you'll get more comfortable with over the course of the term. It's fine if that's still kind of a foreign, weird thing to be doing, making markdown documents. Last week, of course, we did visualization with ggplot. We're going to spend sort of the rest of the term doing some bits of visualization, just about everything else we do, and learning how to build visualization into a data processing and analysis pipeline over the next few weeks. And we've kind of peeked at how we manipulate data to, say, visualize it or something like that. But we've only kind of gotten a sneak peek. Today's all going to be about how we manipulate and summarize data, in particular using the DeepLiar package that I introduced last week. DeepLiar can do a lot of things and covers most of the tasks people will commonly do with flat files, that is any kind of spreadsheet style set of data, or pretty much any data frame. Okay, so the theme of today is death to spreadsheets. So we're going to talk about DeepLiar, which is a package that, as I say up here, will let you do just about any calculation you've ever tried to do in something like Excel, but also something like Stata, SPSS, SAS, Minitab, whatever, more transparently, reproducibly, and importantly, safely, especially than Excel. The idea here is you don't want to be the next sad research assistant who will forever be known as being responsible for the Excel error that caused a massive scandal. Reinhard and Rogoff 2010 was the case where a big, high-impactful paper came out showing that basically GDP to debt ratios, high GDP to debt ratios were causing slow to nil growth in countries. Right now, I see it. Thumbs up. Steve. It turns out that this finding that they said was this massive finding showing that we need to like shrink GDP to debt ratios in countries was actually because their research assistant mistyped a formula on their Excel spreadsheet that left out all of the high-income countries from this calculation. So of course the relationship wasn't there at all. And then Reinhard and Rogoff actually, in very classic fashion, decided that, well, even though the data don't say that, we're still going to defend that because we got paid lots of money to do lots of talks on this topic later on. So it's still kind of an ongoing scandal. But yeah, don't be that. Yeah, I'm going to teach you guys how to avoid doing that. Or at least, you know, make it harder for you to do that. There's still a way. Okay, so first part of the talk is modifying data frames with DeepLiar. Okay, so first thing I want to talk about, which I introduced a little bit last week, is pipes. So DeepLiar uses the Magrider forward pipe operator, which I usually just call a pipe, and most people who work in R usually refer to just as a pipe. There's actually different types of pipe, and technically it's this Magrider forward pipe operator. You'll never see anybody actually call it that full name. But if you do get into more advanced sort of R programming with pipes, you can go look in the Magrider package, and there's about a dozen different pipes for doing different things. I basically only really use this pipe, and then maybe 1 out of every 50 times I use a pipe, I'll use a different type 1, but no reason to cover in this class. So if you're writing like a script or an R&D file, if you type Control-Shift-M, or I think it's Option-Shift-M on a Mac, it will insert a pipe. You might have to play around and see it's one of those keys on a Mac to do it. That will insert a pipe so you don't have to constantly type %, arrow %. Is that right? Alt-Shift?
Yeah, that's right for Mac too.
Boom. Okay. Okay. So the way pipes work is pipes take whatever object is on the left side of the pipe and apply whatever function is on the right side. In mathematical terms, it's function of y equals function of x, y. You would read them out loud as this and then like this. So if I do something like take our Gapminder data, I would say Gapminder data, and then filter so that country equals Canada, and then get head the first 2 observations. They're read left to right. Pipes save us from writing a lot of extra things, because you'll notice here I didn't have to do like Gapminder $country in here, which is the way you have to subset it using base R stuff, and they allow chaining left to right. Chaining like that makes things much more readable, and because it makes it more readable, and the goal, in my opinion, the goal for teaching programming and for using it is to write code that you can understand just by looking at it, so you don't have to litter it with comments. Writing literate, easy to read code is important. pipes make your code much more readable because it reads left to right, top to bottom.
Chuck?
Yes?
So, and without the piping, you'd have to like attach Gapminder first and then you could do it?
You could attach. I would say that attach. I'm a firm believer that the attach function in R should be fully removed from R, and that no one should ever attach anything, because attach is a quick way to rapidly destroy your entire global environment by populating lots and lots and lots of crap you don't want in there. For instance, I often work with data frames that have 50, 60, 70,000 columns. If I attach that, my global environment now has 50, 60, 70,000 objects in it. RStudio tends to get very upset about that. Don't attach things. Instead, figure out ways to avoid attaching things. And the way to do that is to put things into functions like this.
So that's what, essentially, that's what it's doing, right?
Not exactly. So what it's doing is I'm saying, okay, Gapminder data here, this pipe just looks like an operator. It behaves as if it's sending this into here, but in reality what the pipe operator is doing is it's taking all code that occurs after this pipe operator and wrapping it inside of a hidden function you can't see that assigns that data within that, so attaches it within that environment. That environment is deleted once the function completes running. That's technical, and that's called scoping. I don't cover that in this class. If you want to know about scoping, computer science is your place to go. Anyway, the idea is that this is the same as saying, like, filter Gapminder, country. It's the exact same thing. Gapminder is just going into that first argument here. There's a little bit more going on under the hood, but you can treat it that way. So, pipes, in my opinion, are clearest to read if every function in that piping chain is on its own separate line. I pretty much will always do one thing per line. A line of code should do exactly one thing whenever possible, and only one thing. I'm occasionally inconsistent here because I have to compress everything to fit on the slides, but in general you can kind of tut at me if I ever have more than one thing going on in a single line of code. And the reason for that is that people find it much easier to go up and down than left and right when handling things. That's why data frame, like data, are much easier to read if you have like 5 columns and 10,000 rows than 10,000 columns and 5 rows. It's just kind of the way we work. We're used to going top to bottom on things, which is why a lot of this class is going to be about making things taller and narrower, which is called tidy data. We'll get to that next week. Okay, so in general, pipes work like this. Take some data, do the first thing, and then you can give it some arguments over here. Say with this, you pipe to the next thing, you do this next thing. Feel free to chain hundreds of these together in one go. You can do as many as you want. It just keeps being like, do one thing, do the next thing, do the next thing, do the next thing, do the next thing. The way I tend to write my pipes is I will pipe my data into this, I will run it and see what happens. If it does what I'm expecting, great, write the next thing. If it doesn't, I stop and figure out what I messed up in that first one. This applies to pretty much everything you do in R. Run small segments and then build on top of them. If you write a whole lot of code in one go, you don't know where the error is that's going to happen. But if you do one line at a time and run it, you'll know where the error is because it's whatever you added last. Okay, so stuff that is on the left side of the pipe gets passed to the first argument of whatever function is on the right. You can then add any arbitrary number of functions, or not functions, but arguments to the right of that, separated by commas. But the first argument will always be whatever is piped into it, unless you specify otherwise. If you're finding yourself piping into a function where the data are not the first argument, for instance, linear model in R, if you put a period in, it will pipe this, for instance, Yugoslavia, instead of being piped as the first argument, goes to wherever a period is. If you have some function where you need to make the input on the left side go into 2 places at the same time, you could put in the period twice and it will pipe into both of those locations. This is nice and more flexible if you're working with functions that don't take data as their first argument. The thing you might now be realizing is that we've piped into a bunch of things, but everything we've piped into, we haven't had to use the period. That's because every function in the tidyverse takes data as its first argument. That's why ggplot takes data as its first argument, so you can pipe into it without having to do period. But a lot of things in R do not take data as their first argument. Most models do not take data as their first argument. You can pipe it to the period. And you could say, like, well, I could just run a linear model by going lm pop year data equals Gapminder. You could, but this is the way I reflexively write it, because I'm used to piping everything. If you get used to piping everything, this turns out to be nice and like a native way to look at it. Because the way I think about it, and I think about everything in sort of this DeepLiar framework is I'm starting with something, and that is going to be like the building blocks of some output. In this case, I'm saying, okay, we're starting with the Yugoslavia data. What do I want to do with it? Oh, I want to run a model on it. Well, that still starts with the data. Start with the data, then I run a model on it. I might then pipe this linear model output to something else. I could pipe this into a plotting function. I could pipe it into a predict function. If I have time, I'm going to put together some examples of how to pipe data like into a linear model, then into functions that will run predictions, generate counterfactuals, and then pump them out to a ggplot to do nice plots like the one I showed at the end of the ggplot lecture last week. I'll probably put that together for lecture 11. I have some of it in lecture 10 that's a little bit more simplified. Anyway, piping between things is really easy and really useful. Okay, so the first core, actually, let me back up. Does this all make sense? Does piping make sense? It's really important, yeah.
Just so the last row, does it mean that the data is Yugoslavia?
Yes. Yugoslavia is a data frame that I created last week when I was doing slides. I filtered out all the countries that were in former Yugoslavia. So this would be a data frame. In this case, I'm not actually running this code. This is just an example. I have eval equals false turned on in this chunk. But yeah, that would be a data frame. Any other questions? Good beans. Okay, so the first DeepLiar function I want to talk about, and one of the most commonly used ones, is filter. We used filter a bunch last week, and pretty much everyone used it in their homeworks that I've looked at least. It's for subsetting data or subsetting down to specific rows in your data. It works like this. You take some sort of data set, you send it to the filter command, and you give it some logical condition that must be satisfied to keep those rows in the data. In this case, I would say for the Gapminder data, whenever the variable country is equal to Canada, keep those rows. Anytime that is false, anytime country is not equal to exactly Canada, just remove those rows. And like anything else we pipe, assignment happens way up at the top. So we're going to say, we're going to create a Canada object. What is Canada created from? It's created from the Gapminder data. Gapminder data filtered in some way. This could be 100 lines of code down here. The assignment would still happen all the way up here. That's how pipes work. Is that clear? Okay. So the Excel analog is just filter in Excel. If you go up into the top well, this is an older version of Excel, but it's still basically the same thing. There's a filter function in Excel that allows you to select, highlight, or do operations on different rows in the data frame based on some sort of condition for some variable. It's exactly the same as what DeepLiar is doing, except we don't have a spreadsheet in front of us. We're doing it programmatically. Okay. So, an operator I've introduced last week, and I think I even glimpsed in the first week, is %in. I'm hitting you guys with it one more time because this is a really important operator that's really useful because it saves you writing a lot of crap. So, there's a common operation we'll want to do, which is filtering rows that are in some set. For instance, with Yugoslavia, I'm going to do here former Yugoslavia. I know that Yugoslavia, or former Yugoslavia, has 6 different modern nations in it, or at least nations in our data set. Bosnia and Herzegovina, Croatia, Macedonia, Montenegro, Serbia, and Slovenia. I want all of those to be in former Yugoslavia, and then I'm going to subset my data down to former Yugoslavia. I could write filter country equals Bosnia and Herzegovina, or, remember the OR operator is the vertical pipe. The vertical pipe sits right above the enter key on your keyboard. You have to hit shift to get it. I could do country equals Bosnia and Herzegovina, or country equals Croatia, or country equals Macedonia, and so on and so forth. I couldn't do and because no country would simultaneously be Bosnia and Herzegovina and Croatia, but I could use lots of ors. All %in does is do all those or statements at the same time instead of you having to type country equals over and over and over again. This says, I want to take the Gapminder data, I want to filter it down so that country equals any one of these things in that vector, former Yugoslavia. It just tests across all of them. As long as one of them is true, it's going to keep that row. It's impossible for multiple ones to be true, but as long as one of them it'll return a true, it'll keep those data. So we get something like this. I did tail Yugoslavia, so it's only going to show the first 2 observations, but we can see that I subset this data. These first 2 are Slovenia, the last one I had there. Does that all make sense there? Makes sense how I use the C command here. C is how we create vectors.
I had an issue with like using or with a factor, or I got an error at least. And so is that me
Using
coding incorrectly?
possibly, you'd have to show me exactly what the code is. Normally you can sort and select things with factors and characters basically the same way like this, but it can depend a little bit. It should be fun. If you're curious, Slack channel it and I'll look at it, or email me if it's a long question.
Okay, thanks.
Okay.
Chuck, one more question.
Yeah.
So the difference between those two vectors, so the former Yugoslavia is one, that's a vector, and then the Yugoslavia is one as well, right?
It's not a vector. This is a
Not
data
vector.
frame.
That's just a data frame.
Yeah, so what I'm doing is I'm taking the whole Gapminder data frame, I'm selecting the rows where country equals former Yugoslavia, but what's actually popping out is the full 1, 2, 3, 4, 5, 6 columns and then some arbitrary number of rows, however many will correspond to these. So yeah, this is a vector, this is a data frame. Nothing in their names indicates which one is which. You have to get class to tell them apart. But yeah, that's a data frame and that's a vector. And then who's next and then you.
Yeah, I'm quick.
Okay.
The previous slide you said that had, sorry, no. Still that slide. So the last row of the comment, you used to show that what a difference. The tail, the 2 row, is that the last 2 row of the Yugoslavia?
Yeah, tail, so the head function shows by default the first like 6 observations of what, or first elements of whatever you give to it. If you gave it a vector, it'd be the first 6 elements of the vector. If you give a data frame to it, it's gonna be the first 6 rows of it. Tail does the same thing. By default, it's the last 6 elements of something. But if I do tail, whatever I want the tail of, comma 2, the second argument is how many observations. I just did 2 because if I did the full 6, it was compressing and knocking off my nice slide borders. So yeah. But it's an example of how that works. That's just the second argument to it. If you did question mark tail, you'll see all the arguments tail can take. Okay.
Can you only use filter in order to generate an object, or could I use that command to, for example, count how many observations I have in Gapminder for those countries you have listed?
You can
there?
exactly do that. So to do that, you do Gapminder, pipe into filter, and then pipe it into nRow function, would tell you the number of rows that are remaining. So I usually, you can use it anyway. Very often if I'm doing plots of something, the data aren't really large, I never create any objects at all. I just do all the filtering, the subset, and everything, pipe it straight into a plot function, and it generates the plot, and I've never created an object at all. I don't like to pollute my global environment by creating objects, and sometimes I think of it as a game to see exactly how much work I can do without ever creating an object in R. I've gotten to the point where I have some things that don't even create any objects, never load an object in the global environment permanently, even including like downloading data and everything like that. They never create an object, they just produce it out and nothing is ever loaded into the global environment. I'm a nerd and I like fun games, but yeah. So no, you don't have to create anything. But if we're going to use it more than once, we do want to create it. In this case, I'm going to use Yugoslavia today. Okay, next. Distinct. Distinct is a really handy, sort of simple function. What distinct does is distinct will reduce your data down to the unique observations for whatever combination of variables you give it. So in this case, I said Gapminder, distinct, continent, and year. What's going to happen is I'm going to get, we see here, these are all Asia, these are all the years, 1952, 57, 62, 67, so on. This is every unique combination of continent and year that exists in the data, discarding all other variables and all redundant cases. So if you want to know something like, let's say you're going to be doing like, close your ears if you're not used to hierarchical linear modeling, but if you're going to do a hierarchical model and you want to know how many second levels you would have, but you have like a second level that's cross-classified, this would tell me, for instance, that I would have exactly 60 level 2 observations if my level 2 consisted of continent and year simultaneously. For panel modeling, this would be what your like sort of panel second level is. Now, unique combinations. But you'll notice it drops every other row that's in the data set, which kind of makes sense, because if you're removing unique cases, whatever was remaining, if those were different across within individual, like Asia 1952 observations, you wouldn't know which row to keep. We'll get to aggregation in a minute. Is it clear how this distinct function works? Okay. Next. As I said, distinct will drop any unused variables. Sometimes you don't want to drop those unused variables. It makes a lot of sense if, for instance, you're dropping to two distinct variables where all of the information, all the other rows, is the same for every observation within those subcategories. You probably just want to keep them. You just want to get rid of redundant observations. Distinct with dot keep all equals true over there, we'll keep all of the other columns that are in the data. Just keep in mind what you're actually doing and have a good idea of why you would decide to keep those if you're using distinct. For instance, if I say distinct continent and year, yeah, I've got Asia in 1952 here, but it's completely arbitrary that Afghanistan is the only country represented in here with its life expectancy popping GDP per cap. This meaning Afghanistan is the only country currently representing Asia in 1952 because it comes first alphabetically. If that's okay and that's your intention, that's fine. But just don't always do dot keep all true. There's a reason it's an option. Yeah.
So it's not same as filtering Asia.
No, it is not the same as filtering. Instead, it's the same as saying, how do I do this? Now, distinct is its own weird thing. So let's say that we have a data frame. We have variable x here, variable y here. Let's say this is 1, 1, 1, 2, 2, 2. This is 1, 2, 2, and this is like 1, 1, 2. If I say distinct xy, what distinct is going to do, so distinct xy on this is going to say, it's going to come to this first row and be like, well, I haven't encountered x equals 1, y equals 1 before. We're going to keep that. Next row, I have not encountered x equals 1 at the same time as y equals 2. I'm going to keep that. I have encountered x equals 1 and y equals 2. We're going to drop that. Let's say there's a z here. This could be A, B, C. I didn't say distinct on that. It doesn't matter. We're still losing this information. Then it comes to here. 2 and 1. Oh, that's new to me. 2 and 1 is old news. Let's get rid of that. 2 and 2. Hey, I like that. That's all distinct does. But it is running top to bottom. So sometimes redundant information. If you were interested in Z, well, you should probably put a Z in distinct too. That's how it works. But sometimes the data you actually have are such that this is A, this is B, B, this is like C, C, and this is D, so it lines up with the levels of the redundancy. Then it's fine to keep distinct or keep all equals true. Does that make sense? It's the kind of thing you'll toy with, you'll get used to it. Okay, super useful function. It's also good for, like, using distinct is nice to then pipe into something like n-row to know your unique cases on a couple different variables or something like that. Use a lot for experimental setups and things to make sure I have a sufficient number of conditions to run like sort of tabular analysis. Okay. Next, something you very often want to do if you're working with really, really large data sets is you want to filter things at random. Well, what's filtering at random? If you're filtering random rows, like just grabbing random rows, we usually call that sampling. Sample underscore n or sample fraction will filter at random, that is grab random rows. If you're working with data like I sometimes do, that's 100 million rows of data, even like my Goliath of a computer I have at home will bog down and die on me if I do that. So instead what I'll do is I'll say like, oh, I want to do a 1% sample of those data. I could take that really large data frame into something more manageable. It's 100,000 observations or something like that, and just say, give me 1%. If you haven't set the seed, which I'm going to talk about in a second, it's going to be a different 1% of the sample every single time you run this function because it's randomly drawing it. Okay. The way it works, for instance, let's say I just want 6 observations from my Yugoslavia data. Remember, there's only 6 countries on my Yugoslavia data, but there's a lot more rows because there's additional rows. Each country has different years for it too. I say Yugoslavia, sample n, size equals 6. That means I want 6 total observations without replacement. If you're doing like simulation studies, you might want replacement. You guys know what sampling with and without replacement is? See, nods, okay. If you don't, you can ask. Okay, so this would return this data frame. It's 6 random observations, so you can see that there's a few different countries, a bunch of different years are represented. Just a random sample. Now, oh yeah.
Since you mentioned sampling a certain percentage of your data, is there an easy way to define the size as a percentage of your data?
Yeah, the way to do it is is actually, instead of using sample n, use the sample frac here, and instead of size here, you just give a proportion. And so you'd say, like, I want to sample 0.6, that would get you 60% of all the data. Yeah. So there's a shortcut for it. Sample fraction is exactly equivalent of, put a setting size equals 6 here, doing like using some mathematical function of n row. So you could actually do it manually. I use sample fraction because I'm lazy, and it works. Okay. So, with regard to random numbers, I have to go on a slight rant tangent about random numbers because I'm into computer programming. Random numbers are really, really hard to generate well. And so there's an entire branch of computer science and algorithms and math that's about how do we generate pseudo-random numbers. That is, numbers that look like they're random for all intents and purposes, because computers actually can't produce truly unique numbers. There's some algorithm producing everything. So, because they can't produce anything that's truly random like that, they have something underlying them called a seed. The seed of a random sample is where it begins on, so in the case of a Mersenne twister, which is the type of algorithm used to generate random samples in R by default, it's the most commonly used one, it's very good. Imagine that you have a big spiral. Every location on this spiral is a different, very large number. I think it's, by default, they're all 64-bit integers or something like that. 64-bit integers are really fucking big. Basically, if you don't set a seed in R, what it does is it randomly says, we're going to start right here. But then the way the algorithm works is that based on some algorithm, it just jumps to different locations going down the spiral, which are systematically distributed along it. As long as you don't continuously draw, I think with the Mersenne twister, it's about 2 to the 19,000 samples, you won't get a repeating number with a Mersenne twister. That is a really big number, so usually you don't worry about it, but it's very, very high. Anyway, if you want to always begin at the same location on this numerical spiral, let's say you're doing a simulation study, you always want to draw the exact same random numbers every time, set seed, and give it the same number. Now, for the duration of the entire R session you're in, your random numbers will always come up exactly the same. Not the same in every single function, but as long as you call the same functions in the same order, they will produce the same random result every time. Because all you've done is said, I'm going to begin here on this twister and ride down it the exact same way, because once you select a starting location, it's deterministic. Okay.
You said session, so like when you closed out, you get different results?
Now, if you open it back up, as long as the seed is set to the same number and the functions are in the same order, it will be exactly the same. But it means that for the entire duration of all commands after that set seed, they will all be the same. If you change the order of them, they would not, because the first function would be here, the second function here, the third function here, right? Anyway, this is one of those technical things that isn't too important, but if you're in some CSSS stats class and you want to make sure that your simulation derived from something that you have to do for a homework assignment always comes out the same way, you can do that. Also means that, for instance, sometimes you'll do a random draw on one of those things and you'll get some really, just on pure chance, really ugly distribution that has really ugly plots. Maybe increment it 1 and watch it go away. You can massage it a little bit. It's a homework, that's okay. Okay, so, tangent over. Okay, so, another really common operation we want to do on data is we want to arrange it based on some variables. We just want to sort our data. DeepLiar makes this really easy. I can take my Yugoslavia data. Let's say what I want is I want to make it so it goes from the lowest year to the highest year, but within year I want it to go from the highest population to the lowest population country. That is the syntax for this. In this case, the data are now arranged so that the years are increasing. So it starts with 1952, then goes to 1957, and then so on and so forth. But within the year 1952, it's the highest population country first, going all the way down to the lowest population country. Does that make sense? You can put an arbitrarily long list of variables to sort by. It will sort by the first, then within those, sort by the second, then within those, sort by the third, and so on. Just how you arrange data. It's important to do before you go into some tabular analysis of some kind. If you send data arranged like this into ggplot, it will save that arrangement of them basically never, because those are about factor levels, which we're going to talk about later. But for doing tabular stuff, arranging is nice.
The DESC that's descending. So if you didn't have that, it would sort from the
Yep.
smallest to largest.
By default, most sorting algorithms in computer science arrange from smallest to largest. They count upward. When very often in like the science and stuff, we're actually interested in the largest value first. So just remember you have to put descending if you want largest value first.
Chuck, when you run this, I just ran that code.
Mm-hmm.
It has this cool thing where it shows 1 of 10 rows, but then you have 6 other pages that you can use.
Yeah, you can browse through them.
It's really cool.
Yeah, no. Markdown notebooks. So if you have a Markdown document open in your RStudio, RStudio is actually loading it as a type of format called a notebook. It's basically the same thing as a Jupyter or IPython notebook. If you're used to Python, it dynamically produces HTML widgets as it goes. So those like little browsable tables that appear in your R Markdown document, it's actually rendering a little mini web page in CSS and drawing that stuff that's like accessible in there. RStudio is really, really cool. It's very sophisticated. It's also why you can actually embed those things. Like I can embed these in my slides. If I make my code run to the end of the line, you guys don't see it because I avoid doing it. It will actually pop up a scroll bar that you can scroll back and forth. Like these things are like live web pages. It's just RStudio stuff that happens behind the scenes. I love it. Anyway. Okay. Now, keeping columns. So we've talked about how we filter down to specific rows. Very often we only want specific columns in a data set. Like I said before, I work with data frames that are really gigantic all the time, but I generally don't want to be working with anything that has 40,000 columns in it all the time. That's uselessly massive. We want to be able to select down to specific columns. We do that with the select function. Select has syntax very different from filter. Because we have an expectation, we have way fewer columns than we have rows, we don't tend to select things based on some sort of logical like expression. Instead, we just name the variables we want to keep or the variables we want to get rid of. The syntax works like this. I'm taking the Yugoslavia data and I'm saying, okay, the only variables I actually care about are country, year, population. Then I just got head, the first 4 observations. Well, now all I have is country, year, and population. We've selected just those columns. If you do not name a variable, it just hucks it out the window, it's gone. Straightforward? Yeah, it's pretty easy. Well, sometimes you have lots and lots and lots of columns you want to keep, but you only want to get rid of one of them. Well, you can do negative selection in select. You could instead say, I want to drop specific columns, but keep all of the rest of them. So instead, you just put a minus before the things you want to get rid of. So you could say Yugoslavia select. Now I want to drop continent, I want to drop population, I want to drop life expectancy. Well, what's remaining? Country, year, and GDP per capita. So either type of selection works. You obviously can't use both types of selection at the same time because they're mutually exclusive, but pick whichever one makes the most sense. Very often you're only dropping one column. Very often you're only wanting to keep one column. That's how you do it. Any questions about that? Okay. Next, select has helper functions. So sometimes we'll be working on data sets. This is that data set I was talking about that has 40, 50,000 columns. This is what I call a very small extract from it. It still has 292 columns, but it's a small extract from the Denver Youth Survey. So maybe you have something where you know that all of the variables that you want to keep follow some sort of pattern, right? You can do in DeepLiar something like, let's say I want every marriage. These are age year variables. So was somebody married at age 10? Marriage 10 captures that. At age 11, 12, 13, 14, 15. At those ages was this person married? Well, if I've got these variables from 10 to 27, like I do in this data set, or 26 in this particular extract, I want to select all the marriage ones, but I don't want to type married 10, married 11, married 12. I don't want to type them all out. So what I can say in DeepLiar is, take the Denver Youth Survey, select starts with married, just the word married. This will extract every variable whose name begins with the string married. Or maybe I want all the variables in this data set. You can see I have ones for marriage, but I also have ones for were they in school or not, and things like that. Maybe I just want the ones that correspond to them at age 18. Well, I've made all the variables, so age is always the last thing at the end of the variable. I could say, well, select ends with 18, and now I've got all the variables that correspond to them at 18 because they all end with 18. This is why uniform variable names are really nice too, because you can start to do things like this and do all your variables at once if you have a uniform naming scheme. Does that make sense? Helper functions are great. The neat thing, these helper functions like starts with and ends with can also go inside of other functions in DeepLiar we're going to talk about, like aggregation and mutating functions, which we're going to get to here in a second. Okay. Next. The select function can also be used to rename columns. So, if you're in select, you can say Yugoslavia select life underscore expectancy equals life exp. The thing on the left is going to be the new variable name for that, and that's going to be its old variable name here. You can see I did select that, and now I have life expectancy spelled out the way I said there. So select allows you to select particular columns and simultaneously rename them if you want. Okay? But because it's select, it will drop any columns you don't mention at the same time. If you want to do both those operations at the same time, it's great. But if you don't, you can use the rename function. Rename has the exact same syntax as select. The difference is it does not drop columns you don't mention. So here I said Yugoslavia. I selected country year life expectancy, but then I only renamed life expectancy. All the other columns stay. Pretty easy. Does that make sense? That's why I like DeepLiar. It just kind of makes sense. You just got to learn the verb you need to use. In DeepLiar, they refer to all the functions in DeepLiar referred to as verbs. It's this kind of grammar of graphics, grammar of data thing that Hadley Wickham loves. Yeah, if you know the verb, it's usually pretty obvious how it works. Okay, so another tangential rant. So, column naming practices. So, a good column name, a good variable name in data should be self-describing. It should be obvious what it is. Do not use inscrutable abbreviations just to save yourself a little bit of typing, because RStudio and any good IDE you'll ever use will have auto-completion that takes away the pain of writing long variable names. It will pop something up, you can hit tab to accept it, right? Use autocomplete. You do not want to have a data set where all of your variables are things like var1, var2, var3, because God forbid you lose your code book, right? I know some people who are from older, from bygone eras. I was actually just talking to one of my faculty members. He's like, I like everything named var1 and var2. I'm like, what, do you remember all of those? And he's like, no. It's like, no, you'll lose that stuff. You'll embed it in there. There's no reason not to have long, or at least, I don't mean overly long. Don't write sentences. But, 2 words is great. Maybe separated by an underscore. If you don't like underscores, use a period. Be consistent. Yeah. Another thing. Valid naked column names in R can contain upper and lowercase letters. They can contain numbers, periods, and underscores. Pretty much no other special characters, but they can contain those. They have to start with a letter, or a period, or an underscore. But they can't be completely, you cannot use just the word true or the word if. These are things reserved for flow control and for logical statements. You can't use those, but you're basically free otherwise with what you want to use. They are, however, case sensitive. Now, this is my own pet peeve, do whatever you want. I'm a firm believer that uppercase is evil and should be avoided whenever possible. I like lowercase and underscores. That's me, because I always forget case sensitivity. Our brain very easily remembers how to spell something and how to separate words, that is underscores, but we tend not to remember capitalization too well. So mixing capital and lowercase, I think, is bad style. A lot of people think it's bad style. Unfortunately, the people who designed R did not think it was bad style, so there's a lot of functions, especially old functions, that have mixed case. It's totally arbitrary. People have stopped doing that. You'll notice everything in DeepLiar, ggplot is all lowercase. That's good style. Okay. Interestingly enough, in R, you can include spaces and reserved words inside your variable names if you enclose those variable names in backticks. Okay? It's really useful sometimes to have a variable name with a space in it if you don't want to modify something like your axis labels in ggplot. You can actually just name it with the spaces in it, send it straight to ggplot, and it will just plot with those spaces in it. Okay? Same thing with panda or something. Show you an example. Okay, let's take these Yugoslavia data I have again. I'm going to filter down to just Serbia, year and life expectancy. I'm rename year to be uppercase here because I'm just going to make a table. But then I did life expectancy with a space in it. Because it's in backticks, R knows that everything inside of those backticks is a single object. It treats it like, it just says, okay, I see a backtick. No matter what comes until I encounter the next backtick, it's all the same thing. Okay? Life expectancy equals life exp. I get head on that, and then I send it to pander. And now in this table, life expectancy has a nice space in it as if I manually adjusted that column name. But I didn't. I made the variable name that. I usually only do this right before it goes into a table or a plot, because it's a little awkward to always have to do backtick typed out with a space and all that kind of stuff. But if you want to, you could always store it that way and just have that be your personal style. Do what you want. Does that make sense? It's not too complex, and you don't have to use it if you don't want to, so it's the best kind of thing. Okay, so next, and probably one of the most important things, most people are probably interested in creating or calculating new columns in their data. This is an operation you do all the time. You want to make some sort of new variable out of existing variables. In DeepLiar, you do it using the mutate function. So, it works like this. Take my Yugoslavia data, I'm filtering again down to Serbia, these 3 columns I'm interested in. I want a new variable that is the population of these countries in millions. To do that, I say population million equals the existing population variable divided by 1 million. It's just simple math I'm included in here. Then I use my demographically inappropriate life expectancy past 40 calculation, which is equal to life expectancy minus the first 40 years. I get something that looks like this. My original columns, year, population, life expectancy, but now I have population in millions, which is just this divided by a million, right? And then life expectancy past 40, which is just life expectancy minus 40, right? Makes sense. Mutate makes it really easy to work with math. You could, instead of doing something like population divided by a million, we could do something like, oh, I want to know, what would be good? Life expectancy per dollar of GDP. You could do like life expectancy per GDP just equal to life expectancy divided by GDP per capita. You could use 2 variables in the calculation. You could use an arbitrary number of variables in the calculation. That make sense? I've been doing a lot of this over the term, so it's pretty easy. And you get lots of experience. And note in here that I calculated 2 different variables inside one mutate command. Like filter, like other DeepLiar type things, you can do multiple calculations inside of a single command. You could even do a calculation where this variable down here could actually rely on this variable before it. DeepLiar calculates these variables in order rather than simultaneously, so you can make one variable that is then built on and then is then built on by another one. I don't recommend doing that too often. I like making discrete calls, but you can put them all on one if you want. Questions? Okay. Next. A common function you're going to want to use inside of mutate is if-else. If-else is a conditional assignment function. The way it works is it will return some vector of values depending on the result from a logical test. So if we remember when we used filter, what filter does is it performs a logical test, and logical test is just any statement that returns just trues or falses, right? So for instance, country equals Oman returns true whenever it encounters Oman, false whenever it doesn't. If-else takes those kinds of logical statements, but instead of returning the true and the false, it converts it into returning particular values that we want. It's really good for assigning values to a variable, like creating a binary variable, a categorical variable of some kind. The way it works is we have this function if-else. You put a test first. So in here I said x equals y. If this comes back true, if-else will return the first value. If it is false, it will return the second value. If it is neither true nor false, it will return NA. For an example, it works like this. I create a new little vector here. It's called an example. It contains 1, 0, NA, and -2. My condition is example greater than 0? If so, return the text positive. If false, return not positive. The result of this is positive because this is greater than 0, not positive because this is not greater than 0, NA because it's an NA and you can't do a logical test like this on an NA, and then not positive because negative 2 is not positive. Does this make sense what's happening? It's just running down that vector, boom, 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 and doing that test, and then returning some value as it goes.
What if you have missing data?
Missing data will be NAs. And so NAs, it will return NA. So this means you have to explicitly sort of handle your NAs, which we're going to talk about.
Sometimes it's not so like cut and dry of like a binary thing. So
Mhm.
you didn't want to overwrite.
You can do one.
What?
You have to do what? Or
So if you didn't want to overwrite something, like make it a 1 or a 0, is there a way to just like make it just for the yes, for the true function?
yeah, replace only the S's or replace only the No's?
Yeah.
Absolutely, and I'm going to show an example of that. Yeah. Yep. Because remember, it just returns the value over here. You could make it so that the thing it returns for false is example. So you're overriding it with itself when it's false. In other words, you're not making a change. Craftiness. That's how it works. I'll show an example. Any other questions on this particularly? Go. Okay, 4 examples. So, what I want is in my Yugoslavia data, I want to create a new column called short country just because I'm tired of typing out Bosnia and Herzegovina. Now, if else country equals this one really long country name, replace it with B and H. Otherwise, just return country again. This is a way of changing sort of only one particular thing. In this case, I'm creating a new variable called short country, but I could easily overwrite country with this. It would just replace that variable. The only modification it would do to it is replace Bosnia and Herzegovina with B and H. Everything else stays the same. The result of it is this. My new short country variable, where it was Bosnia and Herzegovina for country, is now B and H, but this is still Croatia, this is still Montenegro. That's how you do like replacement of a single value in something like this. Easy? Straightforward? Okay.
One more question.
Yeah.
Why do you have to put as character? Like you just can't put country?
Country was a factor originally in the data. And I'm generating, so if you attempt to write a level that is B and H to a factor that does not have that level in it, it's going to say you can't do that. That factor does not contain that level. Because what a factor is a factor is categorical data with an underlying numeric representation that has a fixed number of levels. If you're trying to assign something that is not one of those levels, it's going to give you an error, because that's what it should do. It's saying you're assigning something that can't possibly exist. Because your factor should, in its levels, have every possible value it could ever take. This is why I recommend not converting things over to factor until you're about ready to use them. But if your data come to you as a factor, that's just going to be a thing. So sometimes you need to convert data types. Okay, great question. We're going to spend altogether too much time on factors in week 5 or 6, I think. Yeah. Another question?
Okay, same question.
Oh, same question. Great question. Anything else? Okay. And if you run into odd problems, like you assign something with if-else and just says something like invalid levels, it's probably a factor problem. Slack channel, email me. When in doubt, you run into something that makes no sense, email me. It'll make sense to me. Usually. Sometimes it doesn't. Okay. Recode. This is the one you use when you encounter factors. Yeah.
Sorry, can you back to the? So the row arrange year and short country. So in this row, the data will arrange the year from the smallest to the bigger.
Yep.
And the short country will there no sequence. Oh. Okay.
Yeah. So arrange automatically knows to order numeric things from lowest to highest, and then knows to do character things alphabetically
Okay.
from the beginning to the end. Descending would do it reverse alphabetically. Arrange is a smart function. Just kind of does what you want to. Great question. Okay. Next. Recode is another useful function you might want to use in mutate. Recode is specifically for changing one particular value or one set of values to another value, usually in a factor, but it will work for any numeric variables too. Normally in a numeric variable, you don't just need to change one number. except for the case you're working with some kind of data that were systematically recorded with one wrong number every time that number popped up. It's common with things that turn in NA when they should be zeros, or a 0 when they should be NA. Or if you're loading this data file that hasn't been properly converted, you want to replace all your periods with an NA, you can use Recode for that, or NA. Anyway, yeah. The way it works is, in this case, I've taken my Yugoslavia data, I pipe it into mutate. I'm saying now, country, I'm replacing the original country variable. Country, Recode, Bosnia and Herzegovina. Notice I have it in backticks instead of a string. This is the original value. I'm going to replace this value with this value, B and H. And Montenegro with M. I'm going to leave everything else untouched. Notice I don't have to specify anything. It knows if I don't specifically say to modify it, I just want to leave it alone. Recode is nice like that. Then I want to see every distinct level of country. Notice country is still a factor. Recode didn't try and change it to character or anything, because Recode by default is made for factors. Now, Bosnia and Herzegovina is B and H. Croatia is still Croatia. Montenegro is just a capital M. Serbia and Slovenia are the same. That's how you recode factors or modify factor values very easily. Yeah.
So that's not making a new column.
Nope, this is overriding the old one.
Okay, but why we can't just put like record? Do we always need to put like mutate first? Like,
Yes, we need to put mutate first. Because if you didn't want to put mutate first, you would instead have to say Yugoslavia $country equals recode Yugoslavia $country. Here, what the piping and mutate is doing is it's setting the context for whatever functions are in it to be based on whatever columns are inside Yugoslavia. Mutate is a wrapper for operations going on inside of it.
So it means that mutate a variable, mutate a new column. If the column already exists, the column
Overrides it.
will override
Yes.
the origin.
Everything in R basically works this way, that if you want to modify something that already exists, you're actually just writing over it. You don't modify things, you just write over things. This is actually basically universal. A modifying operation in any computer language or anything is really just overriding some components of it. In R, it's overriding the entire thing, because that's the way
But
R works.
if I just want to generate a new column, I don't want to override.
Nope.
If
You could change that to new underscore country, leave the rest the same, and instead you'd have a column that's new country.
I mean, I don't know. Maybe I forgot there is a variable already named with the same name. I don't want to override. I want to get the notification.
Ah, okay. Well, the thing is that, you want a warning if another variable that already exists.
Yes, I don't want to override. I don't want to generate a new.
Yeah, that is good. That is why you always make sure you use distinct column names and use big informative names. Because if you're using lots of small things, like you name things a lot of var1, var2, and you lose track of how many of those you have, you're going to overwrite them. That's sort of up to you. In this case, it's obvious it should be, you want to work with the smallest number of columns possible. That's the kind of thing that's only really possible if you have a lot of columns. If you're working with a small number of columns, it's basically never going to be a problem. You know everything that's in there. If you have if you have multiple columns that store the same basic data, they shouldn't even be separate columns anyway, so they shouldn't have similar names. I'll talk in the next couple weeks about how you can take many, many columns that all measure more or less the same thing and stitch them together into a single column, and then make your data longer. Because the goal is always to have your data as long as possible and as narrow as possible. We'll get into the philosophy of that in the next 2 weeks. But yeah, no, R will just let you overwrite it, and very rarely will R warn you. R trusts you in many things. R trusts you when writing data, it distrusts you when modeling, because it's written by statisticians. Statisticians are like, well, if I modify my data, I know exactly what I'm doing. Then they're like, ooh, other people are going to use this. Don't trust them when they do stats. It's the philosophy of R. Yeah, but it just does it. Any other questions? Okay. So, sometimes what you want to do is you want to run lots and lots of if-else type statements at the same time. The old way to do this in R was to write lots of if-else statements, sometimes inside of each other, that nested on forever, and they were hideous and just difficult to navigate. And that's how I used to write all of my code, because this function A didn't exist when I first started doing an R, and then I didn't discover it for a couple of years, and then it was life-changing. It's now my favorite function in R. Case when will perform multiple if-else operations sequentially on anything you give it. It's a little complex how it works, but it's really useful for doing things like creating a new categorical variable in a data set based on a bunch of other variables at the same time, or even one variable. The example here I have is I want to create a categorical GDP per capita measure. So what I do is I take my Gapminder data, I pipe it into mutate, I say GDP per capita ordinal equals case when, and then I open up case when. In here I have a bunch of different conditions. If GDP per capita is less than $700, I want that to be a low GDP nation, so I just say low. If GDP per capita is greater than or equal to 700, but less than 800, it is a moderate GDP nation. Otherwise, if it isn't less than 700, or between 700 and 800, just assign it high. The way this works, and the reason there's a true here, is because what case when is doing is it's going down a series of logical statements and stopping when it encounters a true. If I have something that has a country that has a GDP per capita of $900, it's going to go, okay, it's going to replace GDP per capita with $900. It's going to say, okay, $900 is not less than 700. That is false. Next, $900 is greater than or equal to 700, but it's not less than 800, so that is false. It comes down here, there's no statement, there's just a true. It says, oh, I've encountered a true. It sets that value to be high. Does that make sense? What I like to do, if I'm working with some complex operation, usually my true at the end of case when is in all capital letters, error, something went wrong, because every one of my logical statements should cover every possible value. That's how you build error catching into like a DeepLiar one. It's like, okay, I've covered everything, and then suddenly, like, I'll tabulate my data at the end, and I'll be like, error, you did something wrong, dumbass. Like, that's actually the type of code, all right. And it'll be like, ah, shit, and I go, and then what I do is I filter, like, I will filter my new data set, new variable equals you did something wrong, dumbass, and it's going to show me all of those values and what I did wrong. Data munging is an iterative process. Error messages let you track down what's going wrong. Usually it's something like, sometimes in like, I was talking about the Denver Youth Survey back then, sometimes it'll be something truly impossible. Like someone who reported getting married that year and reported not being married that year. Like, how short of does a marriage have to last for it to have never existed? But, I don't know. Celebrity signature. Anyway, yeah. Questions? Cool function. I recommend playing with it. I use this in basically every like data manipulation script I have.
It's always false until something says it's true, right? So.
Well, yeah, I mean, unless it returns an NA. NA is a little bit different. So usually, if you know your data have an NA in them, the first line I usually put is an NA catch. I make it'll be like is GDP per capita NA, and that will return a true in the first part, and then I'll have some kind of NA catch assigned to it.
Okay.
Yeah.
Because I think when I was playing around with some of this stuff, it's like my data always has missing.
Oh yeah, everybody
so
does.
Right, so you just have to put those at the very beginning.
That's what I do.
Okay.
Otherwise, these statements will return NAs as they're going down, and what not to do with an NA.
And that's pretty much like every function in R is you have to like specify what to do with the NA.
Usually, yes.
Okay.
Some things will automatically handle NAs. For instance, like most models will automatically drop rows with NAs, but most data manipulation ones want you to explicitly say you want to do what you want to do with an NA. And that's really good. Like Stata just sort of very often is like, oh, you have NAs, we'll just assume you want to ignore them or not do something. That's fucking horrible, right? Like you don't, if you have like 95% of your data NA and it doesn't tell you that, you might be doing massive operations and actually be using a sample 5% of what you think you are. R just screams at you. It's like, you have one NA, you're upsetting me. Do something with it. That's good. R expects you to like handle these things directly. I love that. When I first moved to R, I'm like, why doesn't it just handle the stuff behind the scenes? It's like, well, handling stuff behind the scenes is bad. It's like, it's always bad. You want it to be explicit. Yeah. I'm going to talk a lot about NAs, I think, here in a minute. Okay. Yeah, after summarizing here. Anyway, summarizing with DeepLiar. Next sort of operation we might want to do is we want to aggregate our data in some way. So what summarize does is it will take rows of our data and it will compute something across multiple rows at the same time. We've been doing this before, doing things like calculating the mean of a vector. The mean is a summary statistic for an entire vector, so is the standard deviation, the sum, and all that kind of stuff. The summarize function can take any function that will aggregate multiple values into a single number. There's a lot of different ways to summarize stuff. In a spreadsheet, like Excel, this is the equivalent of saying something like having a column sum or a column mean at the end of the column. You can just add up all those values into a single number. In DeepLiar, we're going to use the summarize function to do it. Okay, here's an example. Take my Yugoslavia data. I'm going to filter down to the year 1982, and then within the data for 1982, I want to calculate the number of observations in the data, the total population of all countries in 1982 combined, the average life expectancy for all those countries, and then the range of life expectancy in all those countries. That is, whatever country had the maximum life expectancy minus whatever country's life expectancy for the lowest life expectancy. Calculate all those simultaneously for all rows in 1982. This is the result I get. For 1982 in Yugoslavia, well, there's 5 countries. We created that Yugoslavia data set. We know it has 5 countries in it. The total population was about 20 million people. That's a lot of people. The average life expectancy was 71.3, and the difference between the highest life expectancy and lowest was 3.94 years. This is calculated using every row in the Yugoslavia data at the same time. The syntax is really simple, and you can do many different types of aggregation at the same time, just by chaining them together like you would chain together variable creation and mutate. Okay?
If you're going to say, use like functions like sum and mean, can you look at the data with summary?
Yeah, you can with summary, but as we're going to get to in a minute, there's very good reasons for wanting to do it this way. Well, one thing with summary is summary is a weird function, but summary specifically returns a very specific type of summary. It returns your, on a data frame, it returns, for different types of variables, different data. For numeric variables, it returns all of your key percentiles and your mean. But yeah, that's nice. But sometimes we want very specific things. Like we just want to know, the mean, but if this is like a calculation, summary has no easy way. Well, actually, summary by default actually does return a range, but it returns what is the minimum and maximum value. Well, this actually calculates that number. If we want to use these numbers in some other calculation down our chain, we want them in the format like this. But what if you only really want one number? Like if you want, I want to get just the mean, and I want to put it in an in-text inline R code, I would just say, well, I want get the mean of Gapminder $ life expectancy, right? This is for aggregating your whole data frame down. We're going to see why this is really powerful in a second. Any other questions about this? Okay. So, summarize at, and there's also mutate at and things, are functions used for doing something repetitively so you don't have to type a whole bunch of crap. So, let's say you need to calculate the mean and standard deviation of maybe every column in your entire data set, or maybe 3 or 4 columns in your data set, and you don't want to type mean this variable equals mean of variable every time in it. Summarize at lets us use a simple syntax, the same syntax that's in select, to select multiple columns to do this operation over. In this case, I said Yugoslavia, filter down again to 1982, then I want to summarize at these variables, life expectancy and population, and the summaries I want their mean and their standard deviation. It automatically generates variables that are the variable name underscore mean, variable name underscore SD, because those are the names of the functions I gave it. This is the mean of life expectancy, the mean of population, the standard deviation of life expectancy, and the standard deviation of population. You could have a massive list of variables or a massive list of functions. It would just handle all of them without you repetitively typing out every single thing you want. This is really nice for doing lots of summaries at once. And let's say you want to do something like, I had my DYS data again. I have 16 marriage variables. I could say VARS starts with married, in quotes, and it would do mean and standard deviation for all 16 or 17 of those variables that I have. If you have a lot of variables and you want to get all that information, you can do that. Does this make sense? It's pretty easy. Other things you might want. Maybe you want to do some summary across every single column in the data set. So let's say you have some particular piece of data where all the columns are more or less measuring something numeric or something like that. You just want a summary across everything. summarize all, and also mutate all will allow you to summarize or create new variables across every column in the data set at the same time. For that, you don't have to specify columns because you're doing all of them. And then you just say function, mean, and SD. If I have 100 columns, I'm going to get 200 columns out, 100 means and 100 standard deviations. Rarely do I ever use summarize all, because usually at least I have an ID column in my data set, but it's there if you need it. A really useful one, though, is summarize if or mutate if. What this does is it will summarize or mutate all variables that meet some logical condition. So for instance, if I want to select every numeric column in my data set and standardize every single one, this is something common before throwing into like correlation-based models like a structural equation model. I just want everything standardized. I could say summarize if is numeric, get the mean and the standard deviation, or if I want to do it for a structural equation model, I would say is numeric funds standardized. It would standardize every numeric variable in the data set. It would leave alone every other variable in the data set. Which is great. If I want to standardize 40,000 columns at the same time, it uses the same syntax as doing 2. Avoiding typing and repetition is what programming is all about. Make the computer take care of figuring that out. Don't use these a ton, but as you spend more time in R, work with particular data sets, it's nice to know these are there, they exist. You can do it all manually using just mutate or summarize, but it's nice to know there's shortcuts. Okay, so where the true power of the function summarize comes from is by mixing it up with the group by function. What group by does is by itself, group by does nothing. What group by does is it changes how every function call in the pipe chain after it works. So, any functions you run after group by in a series of pipes will be computed within each group that you group by. So typically, you're going to do something like put group by a factor. Maybe do group by continent, and then every calculation you perform after group by is going to be calculated within each continent separately. I'll diagram this in a second. This is like pivot tables in Excel if you're fairly Excel savvy. Okay, this is how it works. So let's say I take my Yugoslavia data. I'm going to group by the year. Then I want to summarize the number of countries is equal to distinct number of countries. Total population is the sum of population. Total GDP per capita is the sum of population times GDP per capita divided by total population. You see I actually use a variable I just calculated here in the next line, and R is perfectly happy with that. Now I get something a little different than what we saw before. Instead of summarize producing one row, summarize is producing one row for each year in the data set, because I said I want to group by year. This is what summarize is useful for and why it's way better than something like the summary command for something in particular. Now I know in every one of these years we have the same number of countries. This is the total population for all countries combined during that year, and that's the total GDP per capita for all of the countries combined in each individual year. This is how you take some data sets, say that's individual level observations, and you aggregate them to groups of some kind. Let's say that we have data where we have a whole bunch of people answered surveys in different neighborhoods in a city, and you want to aggregate it to the means of those people within the neighborhoods. You just say group by neighborhood, aggregate. It takes care of all the stuff under the hood for you. Make sense? I'm going to diagram what's going on here. So, the way group by works, let's say we have some big square where, let's say, these are a whole bunch of observations, these are a whole bunch, but I've already arranged them such that this is group 1, 2, 3, 4. Right? If I say I want to group by, I pipe this into a group by function by group, then say I just want to calculate mean. Let's say there's really only one variable. What it's going to do is it's going to grab all the observations here. It's going to calculate a mean and produce one value here. Then it's going to go down to the next group. It's going to calculate one here. It's going to go down to the next group. It's going to calculate one here, so on and so forth. It's actually taking the data and breaking it up into one data frame for each level of whatever category it is and doing a completely separate operation on each one. You could do this manually by literally separating your subset in your data into 4 different groups and running everything on each of those groups individually. But that would be annoying. Make the computer do it for you. It's super easy to do. You can do this over anything logically that you could group over. You can also make it do things like run models within each group using the per package and things like that we'll get into later in the term, but it just does that. It divides it up for you, it runs a bunch of things, and at the end it collapses them back together into one data frame without you having to tell it how to do any of that. Make sense? Okay. So, grouping can also be used with mutate or filter to do things within the windows. So this is referred to as, if you group something by 1, 2, 3, 4 here, these are referred to as windows in your data. So it's going to do calculations within a given window. You might summarize and produce a single value, but sometimes you don't want to summarize. Sometimes you want to calculate a new variable that's only calculated within this. An example is very often if we have panel data, we want to calculate like a value of a lag, like lag GDP, which is just the GDP from the previous period. We can do that like this. Here I'm going to say, I'm going to select down to these variables, I'm going to filter only for year greater than 2000, greater than or equal to 2002. There's only 2 years that are greater than or equal, it's 2002 and 2007 in the data. Now I'm saying, mutate new variables. Lag population is just going to be equal to the lag of population ordered by year. So I'm just making sure it's in correct year order. Lag population is just the previous year's population value, right? And then population change is equal to the current population minus last year's population, right? The new data frame that pops out has each country an observation in the year 2002, an observation in the year 2007. Why is lag population NA in 2002?
No previous years.
There is no previous year. I filtered my data down to 2002 as the earliest year, so it doesn't go here at this country and look at the previous row. It would if I hadn't grouped my data, but I grouped my data, so it looks at them as if that is the very first observation in its own data frame. Looks up, there's nothing else there. Then, for lag population is just equal to the country's previous population, and the change is equal to the difference between this and this. Window functions are really powerful and really useful. You can probably think of many clever things to do with them over the time you're working with them. DeepLiar makes the syntax very easy to use. So group by gets used a lot, and it makes everything different that happens after. I don't know if I don't specifically say here, but sometimes you want to group by something, do an operation, and then remove the grouping. There's an ungroup function. Pipe into ungroup, and it will destroy whatever groups you currently have. Doesn't lose any data, just wipes out the grouping. You need to do that sometimes if you get weird errors saying like the size of my sample is smaller than the grouping number or something. You'll get weird errors. It's usually because you left something grouped that shouldn't be grouped. Should have a slide on that. I'll add that next year. Anyway, makes sense? Cool. Okay. Next thing, last major topic for today, joining or merging data between data frames. Another really common operation that you're going to have to do a bunch of on this homework today. So, when do we need to join tables? For a lot of different reasons. A common one is maybe you just wanted to calculate columns using criteria that are too complicated to do using case 1 and Ifelse. Maybe you have to do something like summarize your data on some metrics and then merge it back into the previous data, like you did a lot of manipulations. I do that a lot. I'll do an extract, calculate something, merge it back on. Also very common is that we have two different data sets that we just want to put together because they have some sort of common ID to them. Most of the really novel research that pops out in the social sciences is mixing some two types of disparate data together to come up with some sort of unique analysis. It's really common that people just like, oh, I figured out a way to match this thing here with this thing here and write a paper about it. Well, you got to put those things together, and that is usually done through some kind of merge. We're going to talk about direct merges today. That is, there's a clear ID number, like in one data frame you can match an ID number over here. There are ways to do it if there are no IDs shared between them. That's called a fuzzy match. I won't cover that in this class, but know that there are ways to do it. In Excel, this is equivalent to using match or using VLOOKUP. Okay, so in concept, what we're trying to do in a join or in a merge is we just want to merge data frame A with data frame B. When we do that, we need to know conceptually exactly what we want out of that merge. We want to know which rows we keep from A, which rows we keep from B. We want to know which columns we want from each of those two different data frames. And we want to know which columns in A match columns in B. So what are the IDs that are shared between them? You need to know all of these things, like kind of conceptually, before you just jam data together, right? How the joins actually work mechanically, DeepLiar has a lot of different types of joins. The reason for this is that DeepLiar's joining is based on SQL, on the structured query language that is used to access relational databases. There's a lot of different types of join in SQL. Most of the time when I'm working with data, 95% of the time I'm just using left join, but sometimes you want to use the other joins. The way left join works is it will keep every row in the data set A, and notice what I'm doing is I'm taking data set A, piping it into left join, and then the second data set is B. So normally with a left join, or left join is what I usually use, you'll begin with all the rows in A, you're going to finish with every single one of those rows. You're going to match those rows to observations in B. If something in B does not match A, it's going to be discarded. If something in A does not match B, it's going to be kept, and whatever columns are in B are going to get NAs. It's called a left join because you're keeping everything on the left and keeping only the things on the right that match the stuff on the left. The opposite of that is a right join. A right join would discard things on the left that aren't matched in the right. If you want to keep everything in the left data frame and the right data frame, you use a full join. If you only want to keep the things that exist in both data frames, so an ID shared in both, it's called an inner join. All these different types of joins are for different purposes. 95% of the time, I want a left join. Usually I have some key data set I'm working with. I know I want to keep all of it. I just want to add on wherever possible on the right. I also use left join when I know the left and the right perfectly match. Like if every ID is in the right data set, then it doesn't matter if I use a left join, a right join, or a full join. So I just use left join anyway. Just works. Okay. So, don't memorize all of these. Use a left join until it doesn't work. That's my advice. Okay. So, we have to have some kind of criteria to match observations in one data frame to another data frame. We do that in any of these join functions using the by argument. By works like this. If you do not include a by argument at all, DeepLiar just assumes you want to match using every variable in A and B that share the same name. So if we had two data sets that both had country and year in them, it's going to assume, oh, you want to match one-to-one with country and one-to-one with year. If you have two panel data sets of country-year data, that's probably going to work perfectly. If you have two data sets where you have like a person ID and a person ID in the second data set, but those don't line up, like person ID number 1 here is not person ID number 1 and 2, you probably don't want to do that because it's going to match the wrong people across them. Also, maybe you have a year column in dataset A and a year column in dataset B, but you don't want to actually match on those because actually they're the year the record was recorded rather than some useful observation. It's going to try and match on those anyway. So if you have lots of columns with the same names between them, you don't want to leave this argument out. But you can a lot of times. So you can also specify it like this. You could say, I want to match by, in a vector, this variable, and this variable. This will match between the two data sets on variable 1, variable 2, variable 3 between A and B. So this is for naming specific variables. Maybe both the data frames share 5, 6, 7 variable names, but you only want to match on 3 of them. You'd say like this. I want to match on these 3. The other ones that share the same variable names are going to be renamed so they are not the same variable names between the two data sets. It just does it automatically. Now, very often we have two data sets that have some ID shared between them, but those two data sets have different names for the same variable. You can match them like this. You'd say by equals, and this is a named vector. You'd say the variable in data set A that matches in B matches this variable in B. So this would be the name of the variable in A that matches a different variable in B, another variable in A that matches a different variable in B. So you can also specify. Like let's say you have, I work with police data, so I might have something that's like, in my main data set it's incident ID, but in my general offense data it's primary key. I would say Incident ID equals primary key. It knows those actually contain the same information. It merges them together. So the joins are pretty flexible in their body. Now, if there are multiple matches, so if you have, like you're joining by some ID, let's say in the left you have each row is just one person with one ID number, but you match it onto a data set where each person has like 5 entries, you're going to get a row for every possible match. This is actually great, because if what you want is you have something like a data set that has sociodemographic information on people that doesn't change over time, but you want to say match it to their treatment medical records where each person could have gone to the doctor between 1 and 1,000 times. Well, now you have one row for every time they went to the doctor, but they still have their sociodemographic information for every single one of those rows. This is good behavior. If there's a match, you get multiple rows back. Does that make sense? Play with it if it doesn't make sense when you actually have some data to merge. Hint, your homework will involve merging data. You get to mess with it. If you need more complicated joins than the things I covered in these 2 slides, break them down into multiple operations. Alternatively, you could go learn SQL, which has some more advanced joins. I think it's easier to just break it down into a few different join operations. Figure it out. And for the homework or something, if you're trying to figure out how to do some complex join and you spent more than 5 or 10 minutes on it, Slack channel or email, like usual. Okay, questions on that? It's going to be some examples. Okay, so this is the data set that you're going to be using for your homework. These are the NYC Flights 13 data in the NYC Flights 13 package. This is data on every commercial airline, and actually not just every air flight that left from the JFK, LGA, and EWR airports in New York in the year 2013. Big data set. It has 5 different data frames in it. It has a data frame of the actual flights, a data frame of the airlines, a data frame of the airports. So this is metadata in the airports, these airports, but also every airport a flight came from or flew to, all of the individual planes, because each plane has gone on multiple flights, but it tracks the individual planes, and the weather for JFK, LGA, and EWR. These are 5 different data frames. You're going to do a lot of merging these back and forth to come up with different things. You're going to get a lot of practice. To load this data frame, you need to install it. Install.packages NYC Flights 13. Then load it with library. However, if you load it with library, you're not going to get all the NYC Flights 13 data up in your data frame. If you do data NYC Flights 13, it's going to give you an error. There is no NYC Flights 13 object you can load as data. You have to do data flights, data airlines, data airports, data planes, data weather. There's 5 different data frames, so if you want to load them all in your global environment, do that so you can see all of them. Okay. Here's an example of a join using these data. Maybe I want to know the answer to a question like, who manufactures all the different planes that flew to Seattle in 2013? I can take my flights data and say, I want to filter down to the flights that went to SeaTac Airport. SEA is the FAA identification code for SeaTac. I want to select just the tail number. The tail number is just the unique identifier for the plane. Every plane has a tail number. No 2 planes have the same tail number. I'm going to left join these tail numbers to the planes data set, because the planes data set has things like, oh, who manufactured that particular plane? The only thing I care about there is the tail number and the manufacturer. I'm going to join them by tail number. Then going to count all the different manufacturers and arrange them descending by n. Count is a function that will take all the unique values of this and just tally up how many of them there are for each one and produce a variable called n. That's the count. But by default, it's going to be in ascending order. I want to see the other direction, descending, so I say arrange descending n. We see, unsurprisingly, that most planes that flew into Seattle in 2013 were manufactured by Boeing. The next is Airbus. Notice Airbus actually has 2 or 3 different ways to list Airbus. Airbus Industries. If this is real data you were working with for a project, you want to merge those together in some way with Recode or something. NA for 391, that's probably planes that don't have an associated manufacturer with their tail number, probably lots of Cessnas, Learjets, things like that. Barker Jack is a manufacturer of small planes. Sears is a manufacturer of helicopters, I believe. Maybe small planes, I'm not positive. Anyway, these are all the flights that flew to Seattle in 2013. They're manufacturers. I've merged 2 data sets together to do it. What weird thing did I do up here? I actually did a big data operation right here in the middle of my left join function. I said, oh, the only thing I care about in the plane's data frame is the tail number of the manufacturer. You could actually put a pipe and a whole bunch of operations as an argument inside of a function. R is perfectly happy. It's going to interpret that entire thing as being whatever is the output from all those operations. I could have 50 different things going on inside that, and whatever is the product, the end result of all those function calls, will be used as the argument there. This is nice. This saves me from creating an object. As I've said before, I don't like creating objects unless I have to, so I did it. Does that make sense? Cool. I recommend playing with it yourself. Okay. Another one. Maybe I want to know which airlines had the most flights to Seattle from New York City in 2013. Once again, I'm going to open up by saying I'm going to work with the flights. I'm going to filter down to destinations or CTAC. Now the only thing I care about is the carrier. The carrier is whoever's operating that particular flight. Then I'm going to say left join airlines data to that carrier, group it by the name, tally. Tally works basically like count, except if you have only one variable left, or not only one variable left, but if you have only one grouping variable, it's going to tally on whatever you're grouped by. Then again, arrange descending number. We see that Delta operated the most flights in 2013, followed by United, then Alaska, JetBlue, and American Airlines. The reason I did this instead of just using carrier up here is carrier is an abbreviation for the airlines that is kind of unclear and ambiguous. It's their FAA carrier designation. In the actual airlines data, it has the full names of the carriers, and that's what I wanted. So I joined the data by carrier between the airlines data frame and the flights data frame. Does that make sense what's going on? Cool. Okay, here's another one. Getting more complex here. So what I want to do here is I want to know, is there a relationship between departure delays for flights and the gust speed of wind at the time the flight was departing? Okay? So what I'm going to do is I'm going to take my flight's data. I'm going to select down to the origin, that is wherever the flight was coming out of, the year, month, day, and hour that that flight flew out, and its departure delay, so how long it took from its scheduled time to its actual departure time to leave. I'm going to do an inner join, because I only want where I can match it to the weather data. I'm going to say, join that to weather by the origin, so because I want the weather of wherever those flights were coming from. Then I want to match all the way down to the weather at that year, month, day, and hour. Because I want the wind gust at the very hour the flight flew out, and that's the lowest, most granular time unit I can work with. But the only thing I care about once I've joined the weather data to the flight's data is the departure delay and the wind speed. So once I've made a match with all those variables, I just shrink it down to only the departure delay and the wind gust. I don't care about anything else. So I've shrunk my data down to 2 variables. The next thing I want to do is if either the departure delay or the wind gust is an NA, it's missing data, I'm going to discard it because it's useless to the plot I'm about to make. I just get rid of those missing values. Then, notice I haven't created a single object here. I've piped all of this straight into ggplot. Then I just say my x-axis is going to be wind gust, y is going to be the departure delay. Going to make a scatter plot. And then geom_smooth is going to draw like a best fit line through all of those scatterplot dots. I just pipe it straight in. Never create any objects. I don't plan to use these data again, so why bother creating any objects? It's going to take a second to load this, queue it. There we go. Okay, this is what it looks like. Got wind gusts and delays. Check out those 1,200 mile/hour winds from the surface of Venus sitting over there. Okay? When you get something like this, you probably know that nowhere on Earth has 1,200 mile/hour winds. This is an example of problems in your data, right? It's nice. It's a cool looking plot, but we're not on Venus. I mean, I should have checked destinations. Maybe those flights are re-entering Earth's orbit or something. But we can, who knows? One nice thing though is actually these observations in the most recent data have been fixed. So you won't have any 1,200 mile/hour winds anymore. But I put them back in because I like this plot. So, because this is the kind of thing you'll actually encounter if you work with real data. You'll plot something out and be like, oh, what the hell is that? All the time. So just know, you see something like that, yeah, if it's not possible, it's probably not real. Yeah.
Can you back to the previous slide?
Mm-hmm. It's going to take a second to load up. Okay.
So what if you use the left join rather than the inner join?
What's going to happen if I do a left join instead of that is that I'm going to have a bunch of observations that weren't matched in the weather data. So I'm basically just going to have a lot of things that have NA for all my weather stuff. They're just not going to be matches. They'll get dropped eventually in the plot, but it might kick out a warning that I just dropped like 5,000 rows that don't have matches.
So you put 5 column to match by inner join. It means that all 5 column match. They will select one row.
Yeah. So it's going to create. It's going to return a data frame that has 1 row for every complete match of origin, year, month, day, and hour between the 2 data sets. Yeah.
They match all. They return 1 row when they match all of the 5.
Well, it will actually, if there's any redundancies, it's going to return multiple rows. So, for instance, if I have, I might have 100 flights that take off all within the same hour from the same airport on the same year, month, and day. It's going to be 100 rows, right? Yeah, but they're all totally redundant. I don't want to discard that information. However, if I have a whole bunch of, let's say I have a bunch of weather data when the airport was closed and there were no flights going out of it, I don't want to keep any of those rows of weather. Similarly, if I would have a whole bunch of observations in my flights data that were when the weather station was like malfunctioning and it wasn't on, I don't want any of those rows, so I'm discarding what I'm missing from either data frame. You could do this all with left join too, but inner join here is just an example of the time you want to do it. If I don't care about if I don't care about any data that don't do a perfect match, inner join will just discard on both sides. It's the opposite of a full join, which will keep everything no matter what. Make sense? Convenes. Okay, now it's going to take a second to load that. There we go. And here. Okay, so next thing I want to do is, okay, maybe I want to remove those outliers because I know obviously there shouldn't be wind gusts at 1,200 miles per hour. All I did is I took the same basic syntax I had before. I added into my filter over here. Also, let's filter down so that wind gusts must be below 250 miles per hour. And then I dressed it up a little bit by doing a proper X label, a Y label, and I did theme black and white base size 16 to boost the text up a little bit and make it look nicer. Another thing I did is I removed G on point, so my graphics are being dynamically rendered in these slides, and I don't like how long it was taking to render this slide, so I did remove the G on point, and I just had G on smooth. So this one is fast to render. This is what the mean trend looks like for the average departure delay by wind gusts in mile per hour. It's overfitting a little bit. This should probably be a smoother trend up through here, but in the data there's actually a big dip right here for whatever reason. Yeah, so this is a simple mean trend. On average, as wind gusts go up, departure delays go up. Imagine that. Okay. So, some suggestions. When I say tinkering suggestions, I mean these are sort of things you might do on your homework. That'd be useful. You could answer literally, if you're just not feeling very creative, it's okay. You could just answer literally these sorts of things in your homework. I don't care as long as you're experimenting with stuff. Things you might do are like, see what are the names of the most common destination airports. That is, you get the airport names from that airport data frame, but to get the most common destinations, you have to see what airports the most flights go to. So that's merging 2 data frames together. You might see which airlines fly from New York City to your home city if your home city actually has an airport large enough to get a flight to it from New York City. I had somebody in a class do that for some very small town in Texas and had 1 flight because somebody flew a private jet. Well, you never know. Is there a relationship between departure delays and precipitation? That'd be basically replicating the exact same thing I did with wind gusts, but using the precipitation column instead. You could do something like use the time zone data in airports to convert arrival times to New York City to the original local time of it to see how long flights were. Then you could see like what's the distribution of arrival times for flights leaving over a 24-hour period. You could see when are busy periods in the airport because they're going to have longer departure arrival delays. Okay, so as a warning for this data frame, the flights data frame minute alone has 337,000 rows. So if you do some kind of sloppy join that is like some sort of big full join with a lot of redundancy, this thing is rapidly going to increase in size. If your computer suddenly locks up after doing a join, or it's taking like 10 seconds to do something, Control-C will cancel whatever is currently happening in your console. Yeah, don't do sloppy joins. They might be explosively massive in size. Okay.
So are you suggesting we kind of do sampling?
No, I wouldn't do that. Basically, the only way that this is going to explode in size is if you're doing the wrong type of join. Yeah, if you're actually joining the data, you shouldn't really ever be ending up with more than 336,000 or 337,000 rows, because this is the largest of all the data sets. Well, actually, no, weather data probably has more rows than that, but you shouldn't be ending up with like 10 million rows. That means you did something weird in your join. Just make sure you're joining on the right stuff. But yes, in principle, if data sets where it does make sense to have that many rows, the thing to do would be to sample down. You know, if you legitimately have a data set with 500 million rows, you sample 1% out of that, do all your modeling and stuff with your preliminary models, and then later, once you've settled everything, you run one model on all 500 million rows. That's how you do that. But yeah, working with small samples. We're not going to work with data that large in this class. Okay, so homework 3. Homework 3, pick something, anything to look at in the NYC Flights 13 data, write up an R&D file. You guys know the rigmarole at this point. Upload the R&D file and the HTML file like usual. I want at least once each of mutate, summarize, group by, and any join. Left join's probably the most commonly used one. Go for it, or if you're feeling wild, do something else. Include at least one nicely formatted plot and one table with pander. Honestly, you guys know how to use pander. If you don't have some logical thing to include in a table, don't bother. But the key things are at least one nicely formatted plot. Use nice variable names. Maybe try out using spaces in your variable names, because that's something to mess with. Round your values to 3 or less digits. This time, unlike the previous two, I want all output included in the document echo equals true, so the person who's looking at it can see all of your DeepLiar syntax and all of your plotting syntax used to generate everything. All homeworks going forward in this class, I think, are going to basically have echo equals true everything to display your code. Because from here on out, it's pretty much going to be actual data manipulation stuff rather than making pretty documents. You know how to make them pretty, now we're going to show our code. Okay. Write up a little bit in words, just a sentence or two after something. If you only have one plot, describe more than a sentence or two, show you know what you're doing. Yeah. Again, if you want to see the NYC Flights 13 data frames, you're going to need to load each one, like data flights, data airlines, data airports, data planes, data weather. Load each individual one. You got a week on this, same thing as usual. That's it for today. Questions? Say what? Oh, yeah. I hope it's not due April 17th. Damn it, I knew I forgot to change something in this. It's due next Tuesday. I spent so much time looking over these slides. These slides have dozens of hours into them. And I still forget the damn date. Oh, my God.
Surely there's R code automatically.
Well, the thing is, yeah, but the thing is, it's like the start date of each term, is kind of, it moves around. Well, now you're making me want to do it. What I could do is I could actually scrape the academic calendar and pull down it and set all my dates based on weeks away from the first day of a term. That'd actually be really easy to do. Maybe I'll do that. That'd be fun.
You're welcome.
Yeah, that's an idea.
Quick question for
Yeah.
you. I was trying to follow along and do some of the homework while you were showing code up there.
Mhm.
I can't get one of your lines to work.
Let's see. Here, let me turn this video recording off.